So I would like to ask you to give our young viewers advice how to choose a career, what's important in career and their future lives.
Um, Put it that way, I want to give a message to the students. I learned that from a movie, okay, and it is what the, one of the actors said: pay attention, pay close attention to everything you see. Notice what no one else notices, and you will know what no one else knows. What you see is what you get. What you do from what you get. That's all the points. I think this is a very important message to all the students. So actually, after I learned this one, I think I've changed my perspective of things. Okay, and I hope the student can understand this and yeah. What time should I start? I mean, no. What age? From what age should I start?
Well,
From kid
for yeah, no, it's for teenagers,
or from teenager?
right?
All
So
right.
your background, I would like to know where did you born and which secondary school you went.
Okay,
Very basic stuff.
okay. I was born in Hong Kong, 1962. So this year I'm 60, an old man. Okay, yeah. So when I was young, I like science and technology, really. I did a lot of experiment at home. I made my own steamboat. I made my own rocket. Okay, I've done a lot of things, a lot of experiment. Whatever I can learn from school, whatever I have read the books from library, I try to repeat it in my home, and sometimes with some variations as well, because I want to do something different. And I'm lucky that I can go to uh, a technical school for my secondary education. So there weren't too many technical school in Hong Kong. Oh yeah, I didn't tell you guys. I was born in Hong Kong, right? Okay, and uh, yeah, at that time, so I was so lucky that I went to technical secondary school, Maryknoll Technical Secondary School. Well, Maryknoll is quite, they have it's a serious. Well, they have a school group, okay, and it's Catholic, okay. So I went there for study. It is very interesting that most of the technical school, they have the first 3 years studying technical drawing, um, woodwork, metalwork, and some of the electrical stuff. And then from year 3, you have to select which stream that you are going. So I was lucky that I was, of course, that was my intention to go to the electronic engineering subject stream, and somebody wants to go to the metalwork stream. So I picked electronic engineering. So I start studying electronic engineering when I was like 14 years old.
Wow, that's quite early.
Yeah. So I'm in love with electronic engineering. So actually, besides what the school has taught me, and I went to the library and I studied by myself. I built a lot of projects by myself. Okay, including some fish attraction system,
Okay.
and some of the we built high voltage I mean, so that you can, you know, how to say, give electric shock.
Shock to
Yeah, you know, just to make fun. Okay, I've done a lot of those, and since then, you know, I studied 1 year of preaching. Then I went to well, at that time I wasn't very good at my educational. I mean,
grades, you mean?
grade. Yes, I didn't have very good grade, so I had no chance to go to the daytime university. Well, at that time there are a number of universities uh, which were good at electronic engineering. You know, Hong Kong University is one, Chinese University is another one, and Hong Kong Polytechnic is the other one. So I like Hong Kong Polytechnic. At that time, it wasn't a university; it was a polytechnic. So I went there. I was lucky, although I cannot go to, I couldn't go to the daytime study. I was lucky that I was accepted to be, you know,
Evening
as
school?
as a nighttime study. So I work in the daytime and I study in the nighttime for a number of years. Okay, and during those years, I start my first technology company. Okay, and so I actually worked as an employee for only 3 years before I started my company in at 21, at the age of 21.
I see.
Yes.
But I'm just wondering, you chose as an electronic engineer as your career.
Yeah.
What influenced you that? Who or what influenced you to become more to choose this profession as a career?
I don't know. I don't know. I like both mechanical engineering and electronic engineering, but I think electronic engineering is more attractive to me because, you know, electronic is something that you cannot see. Mechanical engineering to me, okay, is a challenge, but not as much.
I see. Okay.
Yeah, but electronic engineering is just a mystery, and well, they are teaching us how the electron flow, how the electricity flow, you know, the current, the magnetic density, you know, that sort of things. You know, those are the things you cannot see by your naked eye.
I see.
Yeah, but you can do something, and it seems that you can manipulate the electrons. So it is so interesting.
I
Yeah.
see. Okay. Well, you can't pinpoint exact fact or person who influenced you to become this profession, but I would like to ask you what is your learning technique? For example, some people just I visualize stuff, but some people just read to understand stuff. What's your technique for learning? Do you imagine it in your brain, in your head, so that you can draw the actual outlayer? How do you learn?
Yes, you must do it in that way. I think whatever subject that you are learning, okay, no matter history, no matter mathematics, okay, or no matter electronic engineering, so you have to realize, you know, visualize the you know, how the electron flow. So the electronic circuit is just like a river, okay. So and then the flow of water is the current, okay, and then the strength of the wave, the current is the voltage, and then if you put something in the middle, that's resistance, okay. So the more stone you put in the middle of the river, the less current, okay. And well, this is something that you have to do it like that. Even the mathematics, a lot of people treat the numbers as numbers. I would treat it as, you know, like blocks. For example, 1, 2, 3, 4 plus 4, 3, 2, 1, okay? And then it becomes 55555, okay? So if you put it in block, and then you actually flip the block the other way, and you will see that, they're all the same, okay? And by that kind of principle, that you can easily understand what's happening. Yeah, this is what I did in the past.
I see. Okay. Then visualize your question or the phenomenon in your head so that you can see the other angles that teachers or professors trying to teach you in a way, right?
Pardon me?
I mean, if you visualize the idea or phenomenon in your head, so that you can see or understand the basic mechanism of how it's moving, how it's changing, how it's interacting to each other, right? Okay. Wow, that's wonderful. So over the years, you have more than 90 patents in technology.
Yes, I do.
And I was wondering, what's the biggest success of all these projects? What is, if you name one, what is your biggest successful project or innovation?
More than one, to be very frank.
Okay.
Actually, my first project is a very interesting project, because when I was an employee, I worked as an engineer, so I was a production engineer in charge a project that can send, to dial a telephone, okay, to police or to hospital or the fire station, okay, and then when I started to take care of that project, I found that the project is so complicated and which cannot be manufactured. So I developed some testing equipment, and then the testing equipment later on I re-engineer it to become a standard equipment. And then the standard equipment is, I call it a telephone set testing system, and this project helps so many manufacturers that can produce high quality telephone and export to different countries. So I think it's a big achievement. Okay, at that time there are many electronic manufacturers in Hong Kong, but many of them do not have the experience working on producing telephones. And actually, I want to sell my telephone testing equipment. Then I taught them how to make telephone. Okay, that's how I think I really helped them a lot. And for that kind of testing equipment, you cannot imagine. I've sold 2,000 of them. You can imagine one production line can probably produce 1,000 phones per day, and one production line may need 3 to 4 units. Okay, you can imagine for 2,000 units, how many telephones can made out of those testing equipment that I've sold. You can calculate, it's a huge number. And at that time, so I feel, my answer to your question was, I feel that, this is a masterpiece. It helps a lot of people. It changed the telecommunication system. And I helped to make, electronic pulse telephone so popular at that time. And this is one, this is one achievement that I think. And then the second achievement, I think, that was a mechanical engineering project, actually, not electronic engineering project. I had, I love diving, and I love taking photos. That means I love taking photos underwater.
Exactly.
Okay. Yeah, I have a number of camera, digital camera at that time. So I was talking about back to 2000 to 2005 or something like that. Okay.
Early 2000s.
Yeah. At that time, digital camera was very popular. Okay. But most of the digital camera, as you know, they are not waterproof. You cannot put the digital camera underwater to take your the photos. And of course, you can probably buy a plastic bag or something to house the camera so that you can use it underwater. And then, but the plastic bag doesn't give you very good optical quality of the photo. Okay, and somebody would like to buy a hard case with high quality glass window for the digital camera so that you can take high quality picture. So I remember one time I was planning to go for a sun and beach vacation. So I tried to bring my digital camera and try to buy a underwater camera housing, and I found that it's not that easy. Okay, if I want to buy it from Japan, it's gonna take me 3 to 6 months to deliver. But my planning for the vacation was 3 weeks away. Okay, so that means I couldn't have any chance to buy a housing. So I was just wondering why can I produce a housing which is good for any type of digital camera? Okay. Because every digital camera has their own shape, with different location for the shutter button, different location for the on/off button.
Switch, yeah.
Okay, and they are of some has a longer zoom lens, some has shorter one. Okay, how can you produce one housing which can fit for all types of digital camera? It's a big challenge. Of course, you can buy one. As I said, I had the Japanese-made cameras, digital camera, but I think there are millions of people have the same problem as I did. Okay, they want to buy some off the shelf product. Okay, and then just put their camera in and just go for vacation. So I spent some time. So I have to conquer some technical challenge. I have to solve a lot of technical problem. Okay, I have to find the right size. Okay, which can accommodate the most number of digital camera, and also
You mean like in
the size, the height, and then the thickness and the width.
Right?
Okay, yes, and then I need to have optical window big enough for different kind of lens size, and also I need to make the shutter button and the on/off button movable. Movable. Okay, to accommodate different location of the two button.
But it has to be waterproof, right? The
Waterproof,
first requirement.
yeah.
And also the pressure resistance, right?
Yes.
If you go diving in the water.
Yes, that's right. So I built one, I designed one all by myself.
Okay.
To every dimension, every little dimension down to 10 micron, okay, accuracy. And so for the product finally, launch is a 40-meter underwater digital camera housing.
Oh, I see.
So, and the other breakthrough is, it's not just the very practical one. I make it like a collection. So it's so beautiful, so transparent, and with many different colors that you can choose. Okay, and this is the second one, and I gave it a very good name called Seashell.
Seashell, okay.
Seashell. So I think it's a very good name. Personally, I think it's a good name.
Can we have the photo to us? So that
Oh,
we
yes,
can,
yes.
upload
Of course,
it in the
I
video?
can give you a photo. I can give you a sample. Okay. So, within a very short time, then the product became a world famous brand.
Oh, I see.
Yeah, I've sold, tens of thousands of those. Okay. And people love it. People just love it so much. However, when the smartphone came, okay, a lot of people gave up their digital camera, so the wave was gone. So and I'm no longer producing that product. So the product line stopped at around 2013. Okay,
Almost 10 years
2013 or 15. Although a lot of people, I was complaining. The market is was very bad at that time because of the smartphone came into the market, and my friend said, "Why, you are so smart." No, I mean, that's what he said. You are so smart. Why don't you produce one underwater camera housing for smartphones?
Okay.
So I said, no, there is no way to produce a underwater camera housing, underwater housing for digital camera, because for smartphone, because the smartphone is using capacitive touch screen. It's not by pressure, it's not by heat, it's not by any of those. So you need to have the electrical charge exchange to the servers. Yeah, the electrical charge on your finger
and the screen. Right?
and the screen.
I see.
So it's an electrical charge exchange process. So how can you go underwater, and then actually the water is a conductor.
Right.
So so it how should I say it?
It's almost impossible to do this.
Equalize your charge in your whole body.
I
So
see,
you simply, by principle, you cannot do that underwater. So you can do some kind of simple experiment. You put a smartphone into a plastic bag, and then put it over under the water tape, and you turn on the water tape. You try to use your touchscreen. No way.
I see.
Okay. So even that is not impossible. How can you do it underwater? And the water, remember, sometimes it's seawater, sometimes it's fresh water, lake water, river water. So it's so difficult at that time. So I spent a few weeks, and I found a way, and I immediately filed a patent. Okay, I was so happy to build a prototype. On the same day, I remember it was a cold day in November, I believe. So as soon as the prototype was made, I immediately go to the beach and jump into the water. Okay, and then it works. Okay, what's next? Then I have to go to the swimming pool and test it again because the water in the swimming pool is fresh water. The water resistance is much higher than in seawater.
Yep.
So it works. Okay. Then at that time I immediately filed a patent, and now it's 3 years later it become an invention patent because there was nobody that can do that. Okay.
I claim your patent.
Yeah, I claim my patent.
I see. Okay.
So what you told the audience that I have many patents. Actually, many patents came from seashell, underwater housing, because there are a lot of mechanical design which was very unique at that time. Okay, including the lock, including the shutter button, on-off button adjustment mechanism. So the merit was you can use a very small, you can make a very wide range of adjustment within 7.5 centimeter centimeter cube. 7.5 centimeter cube is a very small space.
Exactly.
Yeah, but you have to build. I can remember 13 centimeter by 17 centimeter by 5 centimeter by 5 millimeter. Sorry, I forgot. 13 millimeter by 17 millimeter by 5 millimeter adjustment.
Oh, I see.
So we make good use of that little space, and so.
This is so tiny, right?
It was so tiny that
5.7 square meters, cubic meter, right?
No, I mean the adjustment mechanism. That's the whole. Finally the product can accommodate all the cameras with the size, shorter than 110 millimeter, the height less than 65 millimeter. I remember all the numbers, because all this number is so important to me, because I collect, digital camera dimension almost every day. I even went to Japan because Japan has the most model, okay? And actually, I bring a caliper and to measure the dimension and the location of, of the buttons for every one of them, okay? I make a lot of note, okay? So I can make use of all these number, all these dimensions to design the housing. So finally, it was successful, and the telephone housing was good for more than 1,000 digital camera model.
Oh, I see. Wonderful.
So nearly 98% of the digital camera model available at that time was compatible to my housing.
One universal housing.
Yes, and the digital camera. Back to the smartphone. Okay, and finally I made a very compact housing. For my first product was for iPhone 4. iPhone 3, right? iPhone 4. For iPhone 4, okay. So actually, my wife helped me for the design. So her name is also on the patent.
Oh, really? Okay.
She is one of the inventor, and so I built the first one. Okay, it's a very compact size, and we sold, tens of thousands of those, and many of those went to Germany. Okay, I was quite impressed. So this is my second masterpiece, I would say. Okay, and then lately I have another one. Okay,
You have 3 masterpieces in your life,
yeah, 3 masterpieces.
but the top of the 3, right?
I think I like the seashell one.
Oh,
Okay. And lately I have been heavily involved in a medical device. Okay, so we have a microfluidic biochip. So what we call microfluidic biochip, that means it can manipulate very tiny liquid, very small volume of liquid, which can complete the diagnosis of certain disease. So actually, we built a small analyzer and also the biochip, okay? And then the chip is able to diagnose certain kind of disease within 15 minutes. And also the analyzer is carryable. You can bring it to anywhere you want. So we actually decentralize the capability of the central laboratory to different places, including every clinic, any physician office, every steamboat, cruise, or railway or airplane.
Exactly.
Or even you can do diagnosis in the field with certain wild animals.
Exactly.
Okay.
Well, let me stop you there, because I want to ask you about this project, particularly in the later on. So about the patents, when we imagine about the patents, we always think like it's so hard and so complicated. It has to be masterpiece. But how about young kids or like teenagers? Do they have a chance to get a patent? Is
Oh,
it
yes, why
necessary
not?
to be so complicated, or it has to be super scientific?
No. Patent is, first of all, you have to be you have the novelty. That means nobody has done that before
In the entire human history, right?
in the human history.
Exactly. Okay.
Okay, but I always mention to the little kid, okay, every person has to make, they have 20,000 idea every day, okay, and they have to make 20,000 decision, okay, and somebody just let it go away, and somebody can catch it, okay. So once if you have a new idea, So don't just let it go. It can be the first. It can be how should I say?
I mean, like this idea can change the course of history, right?
Oh yes.
It might be. You never know, right?
Yeah, and you help people. You are helping the humanity. Okay, you help. You make people's life better. Okay, so don't let your idea goes away.
Exactly.
Yeah. This is I've been telling the
Well,
people,
that's true
the
because
children.
every time we think about successful inventors or entrepreneurs, we always think like them idolized.
Yes.
And making it too big and too far to almost impossible to reach there. But just like you said, some of the ideas are simple. Every day we use it, but it can be new knowledge to humankind, right?
Yeah, that's right. Some people say, well, some people just have a lot of idea, but they don't react and they don't handle that, okay? And they never ask the why, okay? And some kids, okay, they are more aggressive. They always ask why, okay? And which is a good beginning, good start. But I think the further away, you can go further and ask yourself why not instead of just why. Why not is important because you are trying to do something against the tradition.
Exactly.
Yeah, I think if you have that kind of mentality, then you can create a lot of great things.
I believe so, yeah. And I think that if you're right, if people don't ask why not, probably humankind still in the cave and looking for a solution for making fire, right?
Yeah,
So-
that's right. That's right. Yeah, you're right.
And another question. People love to talk about their success and achievements,
Yes.
awards.
Yeah.
But I think everybody make achievement one day, but other day they make small failures, big or
Yes.
small.
Yes.
Regardless, they're failures.
Yes.
Can you give us an example that was there any success in your failure in your life that you can share to our audience? And our audience are teenagers mostly, and of course they believe that ideal world there's always success and success.
No,
But in life,
no.
probably success, failure, success, failure. Or
I
it's- can be-
I would say in my career, I would say that it's just like success and failure, and then success and then failure. Well, I think I have more failure than success so far, but you have to learn from there, okay, to prevent the next failure. So the more failure you have, the more you learn. However, okay, don't let the failure encourage you.
No, this is
Yeah, I think that's the most important. Don't let the failure send your passion away.
Thank you. That's wonderful said.
Yeah, this is what I think.
Thank you. And I think lately, because of this software revolution happening in the world,
Yes.
or at least in Mongolia, and
Right.
I think people tend to describe software achievement as an innovation. Innovation means more into application or developing softwares. But how do you define innovation?
Well, innovation is something that nobody has done before. Okay, it can be anything. Okay, well, even a housewife has innovation every day. They try to optimize the cooking method for the children to cook it, more efficient, cook the food nicer or maybe cheaper.
More nutritious, maybe.
Yeah. So I would say everybody, can do that. Okay. It really depends on which area you are focusing on, and whether you learn from there, whether you try to make that come true, and so that you can implement into your life, okay, and then you have to share it to other people so that you can help others.
Well, where I see it, innovation is a very, very broad term.
Right.
It can be science, social sciences, or daily lives,
Yes.
or in any other ways. And we shouldn't box it in only in IT technology or only in science. It can be a broad definition, and if you can, I think everyone makes innovation their daily basis, and the difference is we just defining them as innovation or not.
Yes.
Yeah.
Right.
Okay. Like we discussed before, I'm really, really interested about your current project, that small chip.
Yes.
Can you tell us about it?
The chip, okay. I got a name for it. The brand name I gave it a brand name called Alia, ALIA. Actually, it's a short form of of a long name. The full name is array-based LED induced fluorescent immunoassay. Okay. So we just pick the
letters.
The letters. Okay. So from this product name, the long product name, you realize that we are using fluorescent to make use of the fluorescent, then to detect some to be used on the immunoassay. That means from your immune system. So we check your body whether you contain certain type of a protein detected by some kind of biomarker, okay, and then we have to create a chip. A chip, what we call it is a lab on a chip. Lab on a chip, that means a chip, well, probably the size of a few millimeters square to a few centimeters square. So that means it's like the size of a name card or less, okay? And we have to build all the function in that little piece of chip. Okay, we're not talking about silicon chip. Okay, it can be made from any type of material. Okay, and then we have to build all the structure in the chip so that it can perform a laboratory function. So it can be just one function or multiple function. So you can do a part of the diagnosis job, or you can do a full diagnosis process. So what we have done is to build a chip with full function. That means the chip can actually handle the sample. The sample can be blood, can be saliva, tears, or sweat, or urine, whatsoever. Okay, as long as it's liquid. So we put into the chip, and then the chip can carry the specimen or the sample, and that it has the capability to do the preparation, because then we have some particles, some air bubbles inside your sample that may affect the test, the diagnosis test, and then we need to have we have to seal the chip has to contain a reagent. Why you do the experiment? You do need to handle different types of reagent or chemicals, right? So
depending on the sample, right?
Yeah. Okay. Not only the sample, but also the test reagent. So the chip has to contain some other reagent. Probably 4 to 5 different types of reagent in the chip. Okay, and then so we have to conceal the reagent. And then when the testing is started, we can open the valve, and we have pumps. Okay, we can pump the reagent at our control, at a very high precision flow rate, down to say nanoliter per second. Okay, and then and the chip should also contain a reaction area so that the biomarker can meet the protein or the samples. And then after the reaction, okay, and then all the waste chemical, all the waste reagent and the sample has to go up to a place inside the chip for temporary storage before you dump it, before you dispose it. Okay, so the chip that we build contains all these functions. But how the chip can perform such a diagnosis, and different disease may have different test protocol. So we have an analyzer which can control the chip, okay, externally. Okay, so we can actually, for example, I give an example. We can open the valve, say in the sequence of 1, 2, 3, 4, 5. But also we can control the valve 3, 1, 2,
3, 4,
5, 4, for
7,
example. Yeah.
exactly.
So we can actually control the independently, each valve independently, and each pump independently. Okay.
Wow, that's so sophisticated.
Yes, it's very sophisticated. So and also the analyzer can actually read the ID of different chips, because every chip has an ex-factory day, has an expiry day. Okay, we have to make sure the chip is a good chip, and also the chip is not from the second market. Okay, the chip is originally made by us. Okay, we have to make sure of that, and then the test result can send through the cloud to the cloud through telecommunication network.
I see.
Yeah, this is, I think, what the doctor ultimately would like to see, because in the last 100 years, I would say, doctor give you medication mainly based on the symptom. Okay, but in our system can tell you exactly what kind of disease you have. So the doctor can give the most appropriate medication to the patient, and
So it will save time.
Save medicine, and also some of the disease are highly contagious. Okay,
Just like a COVID, right?
yeah.
So is our test as our chip can detect COVID?
Yes, of course.
I see.
Yes, of course. Okay, and actually we can put different kind of disease in one chip so that it perform multiplex testing, and I think.
You mean like in the chip, same time COVID tests, same time like other.
For example, the influenza A,
I see,
influenza B, and the COVID-19, and we can discriminate. Say if you have flu symptom, but you don't know exactly whether you are COVID-19, you have to stay away from your family, or it's just regular flu. Okay, so for regular flu, you need to take some rest, but for COVID, you better isolate yourself. Right.
I see. Okay. So I think we are coming end of our interview, and I would like to ask, is there any future, or for example, around the world, I think the electronic engineers.
Yes.
Where is this future is heading to? Where is your profession's future looks like to you?
Well, I should put it that way. Every product will not be just one single technology.呢個綜合嗰個technology 叫咩 ？persuasive 啊，係咪？嗰個叫elaborate， 嗰個叫做咩？一個綜合嘅 technology 叫咩？叫做 No，yeah, you can call it integrated.
Combined technology, integrated technology.
Yeah, so every product has the intelligence in the future. No matter a glass for water, a juice bottle. Okay, so in the future, everything will be intelligent. So for intelligent, electronics is the element is a must, but it's not the only one. But also you need to have the software backup. You need to understand, artificial intelligence, probably machine learning, probably some kind of optical, things. I don't know. I just name a few of them. So only electronic is not the only one to build a product in the future. So you have to widen your knowledge base, okay? And so I would say electronic engineering is a good starting because it helps you to understand something which is not visible, as I mentioned in the beginning of the of this session, and then with mechanical engineering and all the engineering, the technology, if you combine them together, so you can produce great things. And for engineer, well, depending on their skill set, they can be of very low salary, or you can get very high salary depending on your skill. And perhaps if combining with your idea, is what I mentioned earlier, you can be an inventor, or you can become an entrepreneur, or you can become a boss. Okay, so it really depends on how you are going to handle, all the little things on your hand. Okay, how are you going to combine them together, and further, and do some further development.
So first of all, thank you for accepting our invitation to coming over to our podcast. Our podcast is called Colors of Science, and as we all know, the science can be so many colors and so many angles, so many layers, and we just want to bring this hidden heroes behind the science, and because of hidden heroes behind the science, our lives are so much sweeter and so much comfortable and so much easier today. And today's our guest is Mr. Yim, my mentor, who's inventor, entrepreneur, and manufacturer, and brilliant Rotarian. And thank you for taking our invitation and coming over. And he's visited Mongolia a very short time. And thank you for squeezing your schedule to have this interview. And we are really, really appreciated, really grateful that you're here.
It's my pleasure. Thank you.
And like we talked about before, most of the questions are almost over. And I want to ask one question about how you learn, or what can we learn from your profession? Because the way I see it, electronic engineer is quite recent profession in comparing to the human history. It's not like physicists or chemists. Electronic engineers become much more recent innovation, right? So since then we are changing to electronic engineering, and currently we are in the phase of electronic cars being very common or high demand in that area.
Yeah. Right. Electronic engineering, comparing to other technologies, rather new, although it's already more than 75 years since we invent semiconductor. I remember. I hope I didn't make mistake. And actually, the lighting source. Okay, as all you guys know about LED, was just invented in 1962. So it is just 60 years ago, and semiconductor was 75 years ago. So it's comparatively new technology, but it can do so much to improve our life. So all of the it's like a a building block for um, all the modern appliances or gadgets. Okay, and so not just looking at your smartphone or the rice cooker at your home or the TV, but electronics is creating the backbone. So it has the internet, you have the big data, you have mass storage, and robotics. They all based on electronics. They all start from electronics. So electronics is a very important technology.
And I think some professions around the world,
Yeah.
there's decreasing number of the professions there choosing this profession as a career. And I think for example, physics teacher or chemical teacher, natural science teachers are decreasing globally. And what do you think about your future of your career? Will they increase in numbers or will it decrease in the future?
Of course, there are many different jobs has decreased. Okay, and I don't agree. Engineering is one, okay, but also even insurance or finance, okay, and all these jobs can be replaced by robot. But engineering is something that I don't think it can be replaced because, a lot of people say robot can build things, but who is going to build robot? That's engineer. So I don't see a dead end. Well, or I don't think I'm very optimistic with a career with engineering.
I see. Okay. Couldn't agree more on the robots. So final question, but it's rather direct. And I wouldn't ask directly about you, but could you tell us the average salary of your profession at the beginning and probably mid 40s?
Myself?
No, as
Oh,
also
okay.
average and worldwide, or in case of Hong Kong or South Asia.
Okay. I think work as an engineer, okay, the salary, I mean, I can only talk about Hong Kong. So it's in a range of, say, 3,000 US dollar to something like 10,000 US dollar, okay. I wouldn't say, it is very, very attractive, but it's not bad, I would say. And, of course, some of the job can give you the opportunity to make more money in short term. But you have to think about whether it is sustainable, okay. And I think the longer you stay in the engineering field, the more you learn, the more skillful you are. And comparing to a lot of the other jobs, so there are a lot of limitation. So you may not good at all time, I would say, and there are a lot of other external reason, economic reason. Okay, so I think engineering is very sustainable career for most of the people, I think.
I see. Well, I think that's the end of our interview. And thank you for your time, and we wish you all the best to your future innovations and success. And thank you for your time.
Thank you very much. Thank you.
Thank you, sir.
For giving me a chance. Thank you.